Okay, the second thing we're learning today is reflections. Okay, now reflections are exactly what they sound like. It's as if you are looking in a mirror and asking yourself, what am I going to see on the other side of that mirror? Okay, so in this particular example, it says reflect this figure across the y-axis. First, it's helpful for us to remember that this is the y-axis. Okay, so it's as if that little green triangle there is like a face, and it's looking at itself in a mirror that's right here, and it's saying, what do I see on the other side? Okay, or another way of thinking about it is this. It's like this entire grid is a piece of paper, and we are folding it in half and pressing down on it really hard so that this green triangle leaves an imprint of itself on this side of the paper. Okay? Well, if we did that, here's what that's going to look like on the other side. It's going to leave an imprint of itself. I don't know why it turned red. Don't ask me. Okay, I'm just doing that to show you the difference between the two sides. Okay? But if we folded it over, pressed it down really hard, and then unfolded the paper, this is what it would look like. It left a perfect imprint of itself on this side. And that's called a reflection. It left a reflection of itself on the other side. Okay? Well, apart from actually being able to fold a piece of paper, we've got to be able to do this, you guessed it, with math and numbers. Okay? So once again, our first step here would be to say, what coordinates did we start with on the left side? Okay, so let's find the coordinates of these points. This coordinate here is negative 2, comma 0. So we've got negative 2, comma 0 right there. This one here, we've got negative 2, positive 1, 2, 3. So negative 2, comma 3. And this one right here in the middle, we had 0, positive 2. 0, comma 2. Okay. So again, we are reflecting this across the y-axis. So what that means actually, if you'll notice, as this point turned into this point, and this one turned into here, and this one turned into, actually it stayed exactly the same, did the y-coordinates move? Did it change how tall or how short it was on this graph? And the answer is no, it didn't. See, this one started here. It didn't go up or down at all. It just moved to the right. This one started here, didn't move up or down, it just moved to the right. This one didn't move at all, so it definitely didn't move up or down. So the y-coordinates did not change. They didn't change at all. But let's talk about the x-coordinates, okay? So this point moved from negative 2, comma 3 to, when we reflected it, now look at what it is. 2, 3. This one changed from negative 2, 0 to 2, 0. And this one actually stayed exactly the same at 0, comma 2. So what changed about these points? Well, if you're observant, you'll notice that the only thing that changed is that the negative sign changed to positive for the x-coordinates. We can kind of say that with 0 too. This was either positive or negative 0, and it changed to positive or negative 0. That doesn't matter because it's 0 either way. Okay? But we find out in the end that the y-coordinates stayed the same, and the x-coordinates changed from negative to positive. Negative to positive. Okay? And that is definitely going to work every single time if you are reflecting something across the y-axis. So across the y-axis, you're just going to change the x-coordinates from positive to negative or from negative to positive. Okay? What if we are reflecting something instead across the x-axis? Okay, if we started off with, once again, this green shape, and we took this piece of paper, and this time we're folding it down across the x-axis, and pushing it together and leaving an imprint, and then unfolding it. So we started with green, and we ended up with the red figure. Okay? Well, once again, let's take a look at the coordinates here. Let's look at this point, just this point at first. What did it start out as? Negative 2, positive 3. Okay, negative 2, comma 3. After we folded it, it's going to match up with this point down here at the bottom. Okay, let's find out what that point is. It's negative 2, negative 3. So negative 2, negative 3. Once again, what changed? The only thing that changed is the y coordinate. X didn't change. X started at negative 2 and ended up at negative 2. Y started at positive 3 and ended up at negative 3. Okay. Does that mean that the only thing that's going to change is the y coordinate is going to change from positive to negative? Let's find out. Let's pick another point. Let's pick this one right here. Okay? Starts off at negative 1, 2, 3, 4, positive 1. So negative 4, comma, 1. And as we folded it down, it became this point right here. That is negative 1, negative 2, negative 3, negative 4, negative 1. Negative 4, comma, negative 1. So, did our rule hold true again? X didn't change. Y changed from positive to negative. The rule held true again. That is going to, in fact, work every single time. Okay? This point here is negative 1, positive 1. Without even looking at where this point is, I know that reflecting it across the x-axis means x is not going to change, so that's going to still be negative 1. Y is going to change from positive to negative. Negative 1, negative 1. The same thing is going to be true about this last point. It started as negative 3, negative 1. Its reflection is negative 3, positive 1. Okay? So just to recap real quick, if you're flipping it across the x-axis, x stays the same, and y changes from positive to negative. If you're flipping it across the y-axis, then y stays the same, and the x changes from positive to negative. And that is how reflections work.